AWS Network Security, VPCs and Subnets. In this video, we will review virtual private clouds, also known as VPCs, and subnets. We will look at a simple example of using subnets to separate public-facing internet traffic from internal traffic. VPCs are the equivalent of having your own network within your AWS account. Generally speaking, people typically have one VPC within their account. You may consider having multiple VPCs if you want to set up multiple environments and have tight control as to whether or not these environments can communicate with each other. Within the VPC, there are multiple network components such as subnets, gateways, route tables, and other utilities that you can use. In this video, we will focus mainly on VPCs and subnets. A VPC can have a very large range of IPs within it. A subnet allows you to subdivide the various blocks of IPs within your VPC. You do this so you can control the traffic between different subnets within your VPC. Control as to whether or not subnets can communicate with each other is controlled by route tables. The typical use case is to have different subnets for different types of traffic. Here is an example of a public-facing application. There are a couple of things to note. First of all, this environment is replicated across two AZs. This provides redundancy just in case one AZ goes down. Furthermore, within an AZ, you'll notice that there are two subnets, a public-facing subnet and a private subnet. The public-facing subnet will receive traffic from the internet, and the route tables are controlled such that that traffic cannot directly enter the private subnet. The private subnet can only be called by components within the public subnet. This is a very common pattern used to separate public-facing internet traffic from internal traffic used by internal compute resources such as RDS and other compute facilities. It's important to note that VPCs, subnets, route tables, gateways, and other utilities provided by AWS work at the IP level. Security groups, by comparison, give you a final level of control. They allow you to define which ports of your components are accessible. For example, you can restrict access to the JDBC port of your RDS cluster to a specific EC2 instance. This would be an example use case where both the network security controls and security groups are used to build a very fine-grained level of network security.